dear guests, we bring to your attention a report on the topic. Study of changes in the intensity of the shine of the polished surface of a natural stone depending on the intensity of its heating. The slide 2. Today, natural facing decorative stone is a fairly high quality and durable natural building material, which is widely used as a decorative material in the decoration of many buildings and structures. Therefore, in addition to physical and mechanical indicators, its aesthetic and decorative characteristics are important when choosing the place of its use. Therefore, the purpose of this study is to establish the main dependencies characterizing the change in the intensity of the polished surface of acid and the main differences of natural stone samples depending on the intensity of their heating. The measurement of the reflective, shiny intensity ability of a polished surface is based on the comparison of the received indicators from the gloss meter with the indicator of the reference surface. The intensity of the shine depends on the mineral composition of the natural stone, on the methods of processing, and changes under the influence of aggressive environmental factors. To establish the main dependencies characterizing the change in the intensity of the polished surface of acid and the main differences of natural stone samples depending on the intensity of their heating, 20 samples from 4 natural stone deposits, 5 samples from each deposit were selected. Samples were taken from acidic variations of natural stone from Lesnikov and Maslov granite deposits and from basic variations, Katerynovsko-Lobrodrite deposit and Rashinsko-Gabro deposit. The dimensions of the samples were 15 x 15 cm. The slide 3. Polishing was performed on a cranked lever machine using a diamond tool. Gloss was measured with a BF 540-5045 photoelectric gloss meter. Heating was carried out in an electric furnace at a rate of 1 min. To temperatures of 200, 400, 600, 800 they were kept for 1 hour at the given temperature and then cooled to a temperature of 20 at a rate of 1 min. Before measuring the gloss, the device was adjusted on a black sample that comes with the device and has a gloss value of 97 units. Gloss was measured on each natural stone sample at 5 points. Measurements were made for 5 samples from each deposit. The obtained results were averaged. The slide 4. When analyzing the initial gloss measurement data, 0 point, in the control samples, it was found that the polished surface of the samples from the Rshchitsky-Gabro deposit has the highest gloss value, and the Lesniki granite deposit has the lowest value. The slide 5. After the measurement and statistical processing of the measurement data, graphical dependencies were obtained, characterizing the change in the intensity of the shine of the polished surface of acidic and basic samples of natural stone, depending on the intensity of their heating. During the study of the gloss of the polished surface of the Lobrodrite samples, it was found that at a temperature of 200 C, a decrease in the gloss indicators was observed in the samples of the Katerynovskoye-Lobrodrite deposit, Fig. 2. At a temperature of 400 C, there is an increase in gloss indicators, followed by a further decrease, and this process continues up to a temperature of 800 C. A similar trend is observed in samples of the Rashinsky-Gabro. The drop in gloss indicators of the polished surface of Lobrodrite samples at a temperature of 200 is explained by the beginning of the destruction of the mineral composition of Lobrodrite. When minerals are heated, diffusion of atoms and molecules occurs, which leads to a change in their crystal structure. In Lobrodrite and Gabro, the main minerals are plagioclase and labrador. When heated, plagioclase begins to decompose into feldspar and anorthite. This process is accompanied by the release of free liquid, which breaks the surface of the sample and reduces its gloss. The increase in gloss indicators at a temperature of 400 is explained by the restoration of the crystalline structure of Lobrodrite. With further heating, the destruction of the mineral composition continues, which leads to a decrease in gloss indicators. A detailed explanation of each stage. 0. The initial state of the sample. The crystal structure of minerals is not disturbed. The gloss is high. 200. The destruction of the mineral composition begins. A liquid is released that breaks the surface of the sample. The gloss decreases. 400. The crystalline structure of minerals is restored. The gloss increases. 600. The destruction of the mineral composition continues. The gloss decreases. 800. The destruction of the mineral composition reaches the maximum level. The gloss is minimal. 6. When natural stone is heated to 800, the greatest decrease in the gloss of the polished surface of natural stone occurred in Orshinsky-Gabbro, 23.7%, Fig. 3. The smallest in Katerinovsky labradorite, 12.1%. Labradorite did not slightly change its luster when heated. The average values of gloss reduction were 21.3% and 18.5% in Lesnikov and Maslov granites, respectively. The greatest decrease in the gloss of the polished surface of natural stone when heated to 800 in Orshinsky-Gabbro is explained by the fact that the main mineral of Gabbro is pyroxene, which is most prone to destruction when heated. At a temperature of 200 C, pyroxene begins to melt, and at a temperature of 600 C or more, it is completely destroyed. This leads to deterioration of the structure of the surface of the sample and a decrease in its gloss. The smallest decrease in the gloss of the polished surface of the natural stone when heated to 800 in Katerinov labradorite can be explained by the fact that the main mineral of labradorite is plagioclase, which is more resistant to heating than pyroxene. At a temperature of 200, plagioclase begins to decompose into feldspar and anorthite, but this process is not accompanied by the release of liquid that would disturb the surface of the sample. At a temperature of 400 C, some restoration of the crystal structure of plagioclase occurs, which also contributes to an increase in gloss. The average values of gloss reduction in the Lesnikov and Maslov granites are explained by the fact that the main minerals in these granites are feldspar and quartz, which have an average resistance to heating. At a temperature of 200 C, feldspar begins to decompose into feldspar and anorthite, and quartz can partially melt. At a temperature of 600 C or more, the destruction of quartz and feldspar occurs, which leads to a decrease in gloss. When labradorite is heated at atmospheric pressure, chemical reactions and transformations of the internal structure of minerals take place. The main processes include phase transition and oxidation of minerals, particularly those containing iron. Unlike granite, labradorite does not contain quartz, so oxidation of Fe and pyroxenes is the main source for changes in the physical and mechanical properties of labradorite at temperatures above 600 C. A temperature of 600 C appears to be the threshold for the initiation of mineral oxidation at atmospheric pressure, starting from a thin coating around the pyroxenes. As the temperature rises, oxidation develops on other crystals. At a temperature of about 800 C, minerals containing Fe2 inclusions are oxidized. Oxidized plagioclase looks like red spots on the surface. Gabbros and labradorites belong to the main rocks and contain 55–98% plagioclase. Therefore, similar processes during heating are also observed on labradorite samples. But studies show that the oxidation of minerals, which is visually observed on all samples of labradorite, begins at a temperature of 300 C.